All right, let's take a look at this function right here. This function is defined as a set of ordered pairs. So, for example, if 1 is your input, -3 is your output, and so on. So before we look at finding an inverse for this, let's take a look at the domain and range. So the domain is all of our inputs. So in this case, 1, 2, 5, and 7 is my domain, and my range is -3, -7, 4, and 2. So let's take a look at the inverse. Something I forgot to mention on the other video. This is the notation that means the inverse of my f function. So if you see this with this little like -1 looking exponent there, that's what that notation means. It means we're finding the inverse of this function. So to find that, excuse my nasty curly braces here, all we're going to do is we're going to take the x and y and reverse them. We're going to switch our inputs and our outputs. Because if you think about it, if I do this function, I plug in this x, I get this y. If I want to invert it, if I plug in this, I need to get this. It brings me back to my original. So my first point is going to be -3, 1, because I'm just reversing this. And then -7, 2, 4, 5, and 2, 7. Okay, so all I've done is I've reversed my x and my y. Now, if I want to find the domain and the range of my inverted function, it's really, really, really easy. Not just looking at here, but all I have to do is my domain becomes the range of my inverse function. The range becomes the domain of my inverse function. So I literally just take these, swap them, and we're done. So my old range is now my domain. My old range is now, or my old domain is now my range. And that's it.